Welcome. Can you hear me? Yes. Welcome to the presentation, to the talk about creating your first linter. I'm gonna try to make it a bit interactive, so I'm gonna ask you also, guys, some questions. So be ready. And the first question is here: what's a linter? Right? I have the answer in the next slide, so don't worry. There's a tool, right, that automatically analyzes source code for potential errors, but also stylistic issues and potential violations of coding conventions, right? Let's say you for sure have seen linters that, for example, tells you if err2 is not null, return error, right? Then you see that there is an error, right? Because normally you are checking a different error than the one you are returning. But you can also use linters to solve and to enforce coding conventions, right? As I mentioned here. And this is what I'm going to try to share with you my knowledge. My name is Manuel Doncel Martos. I always introduce myself as a Java developer because I have been working with Java for a long time. But the last 3 years, I have been working in Go. And I have built many open source linters that I have used in my company. And I'm also interested in domain-driven design. And apart from the programming, I also like to play football. I'm not good, but I like to play. There is no table of content. There are goals that I have for this talk. And the first one is that we are going to learn how to create a linter, right? We have actually two goals, is to create a linter, and we are going to integrate it as a plugin in golangci-lint, right? I guess most of you know golangci-lint. And we are going to use the library that is mandatory to use to include it in golangci-lint. Then we are going to create our first linter. We are going to use it in a small project. And then as a stretch goal, I would love if I'm able to inspire you to create your own linters. Well, let's start first with golangci-lint, a small overview of what's golangci-lint. How many of you are using golangci-lint? So quite a lot, right? Well, as you know, right, it's a linter runner for Go. I guess it's the most used linter in Go, the most used linter runner in Go. There are more than 100 linters. There are also formatters that most of them they are used, for example, to format imports, right? And how it works is very simple, right? You have your own app, and you also have a configuration file in which you enable or disable linters, plus enable the different settings for the different linters, right? This is the library that you need to use if you want to create a linter and integrate it in golangci. Do you know it more or less? Have you ever seen this library? Yeah? We're not going to get into details. It's not needed for this. But it's important that we know these, let's say, 4 concepts of this library, which is the node, the analyzer, the pass, and the diagnosis, right? We are going to go over them really fast. But what this library does is parsing your source code, is building the abstract syntax tree, AST, right? And then every node is a Go spec, right, that we are going to use to build our business logic. Then we have the analyzer. This is where actually the business logic is going to go. So the linter logic is going to go inside the analyzer. And then inside the analyzer, we have these two parameters, which is we have this parameter, which is the pass, which is the one on charge of building the nodes based on the files of your source code files, right? And then once you detect a linter issue, you use this diagnosis to report it, okay? So as a summary, I have it here. So we create the analyzer. In this case, I call it AST sample, right? Then we have the business logic of this linter here. We go through the files. These files give us the nodes. And then in this case, I'm just printing them just to get the view on how it looks, right, the file. This is how it looks, the abstract syntax tree. Basically, you have a top node, which is the file. Then you have the import specs. Then you can have some constants, for example. Then types, definitions, and also eventually the functions, etc. Right? I think the best is to see it in an example. So let's go to here. Is it visible? Visible, or I make it a bit bigger? Yeah? Well, first of all, let me show you. This is the file that we are going to print the abstract syntax tree, so then we can get a bit an idea on how it looks, right? We have obviously the package spec. Then we also have the import spec in this case. Then we have some constant declarations. We see we have one constant declaration, so one const spec, but two constant declarations, right? And then we have also an extract and some methods, right? So how does this look in the abstract syntax tree? Let's check it. Well, it's a big output, but let's go to the top, which is the interesting part. So as we saw, we have the file, right? That's the root node. Then we have a package node. Then we have the identifier for the package, which is main, as we saw before. Then we see also the import spec, right? In this case, the import spec, sorry. And then we see that there is only one value, in this case, the error, right? Then we also see this value spec that contains the constants, in this case, value spec with two constants, right? The two values that we saw before, right? And then, etc., when we see, for example, the extract definition, right? Or we also see the methods, right? The functions in this case, right? So let's pay a bit of attention here, because our linter is going to go in this direction. It's about linting some constants. Let me go to the next slide. Well, and now let's start, right? Let's create our first linter. It's not going to be a fancy linter, unfortunately, because that's not the goal of the presentation. The goal is that we get acquainted with how it works, the library, and how to integrate it in Golang.ci eventually, right? I don't know if you guys are aware of the Uber Go style guidelines. Do you know them? Yeah? No? Yeah. There are also Google ones, but they are also as well Uber, from Uber. They are a bit old. But we are going to implement one of these guidelines from Uber. We're going to create our own linter based on that. And this is our first linter. Maybe it's not the fanciest one, right? But let's see what we think about this. So if we go to let's go, and we see it. So these are the Uber guidelines, right? They are in this repository. For example, they tell you, avoid mutable globals, avoid init, right? So this kind of guidelines. And then eventually, they also tell you this rule. One second. This rule, which basically is telling you, if you have an unexport constant, right, it should be prefixed with an underscore. How many of you are doing this? Again, no one, right? I would not recommend it neither to do it. But there is a reasoning behind, and they explain here the reasoning. It's like you maybe can shadow eventually if you declare the same constant name, right, in a different, eventually later on in a method or a function, right? I guess when they created this it was not so clear in the IDEs that it was shadow, right? Could be, I don't know. But this is one of the rules that they have, and this is one of the rules that we are gonna, this is the linter that we are gonna implement. There are some exceptions to it, and we are gonna see it. So if we go back to the presentation, sorry, it's here. So it's telling you, if it is an unexported constant, it should be prefixed with an underscore, okay? Unless it starts with R. Okay. Can you guys see it? No, it's a bit difficult. Let me maybe do it like this. They say there is an exception, and the exception is if it starts with an R. Okay? So say if the constant is, for example, R user not found, then you should not prefix it with an underscore. Okay? So we have these three rules. If it is unexported, right, doesn't start with an underscore, and doesn't start with R, then we need to lint that issue. Okay? Then I have I think it's quite funny joke now. Let's see if it works. Let's go. Let's implement it, right? I have all the boilerplate code and so on, because so then we focus a bit on the business logic, right? Then I have here this module, right? This unexported constant check. And then, as you see here, we are using this library, right? The library that we were mentioning before. We are also using, sorry, let's make it a bit bigger. We are also using this library to register this as a plugin in golangci-lint, but we will see that later. And then, well, the first, how this library works is to test it, is basically you create a test data folder with this source folder as well. Is it, do you see it, yeah? And then here you create the different test scenarios you want to test, right? Then I created a simple one, for example, in which you declare, well, you have a Go file, right? And then you comment here if you are expecting a linting issue in this line. Okay, so for example, in this case, it's an unexported constant. It doesn't start with R, right? Doesn't start with an underscore. So I'm expecting a linting issue in this line, right? I'm not expecting a linting issue here. I'm not expecting a linting issue here. But I also can declare several constants inside the const spec, right? So then, oh, sorry. I'm expecting also a linting issue here, not here, not here, and not here neither, right? Because this is already an unexported constant with an underscore, right? This library also allows you to propose a solution. So then when you run golangci-lint with the --fix parameter, you can also automatically fix that. And then I have very similar example, right, in which I am expecting, right, this linting issue, but I'm also expecting that after I apply the fix, it has the underscore, right? But then now let's implement the business logic. So we saw the test, and we are going to go here. Let's go, sorry. Is here. So I already, I already filtered for the node that we were looking for, which is the value spec. If you remember from the abstract syntax tree, right? We have the import spec and then eventually the value spec where the constants are gonna go. So I'm already filtering to this node. And then we are gonna here implement the business logic. So give me 1 second. Can you hear me? Yes. So if we remember, right? So then we are gonna go through the names that we can find in the constants, right? And the first rule is like, is it exported? Oh, sorry. Is it exported? Yes, then we continue, right? We're not interested in that constant. We are going to not lint that constant. Then, for example, we will do something like this. Is the name starting with R? Yes, then we are not interested either here. You can always improve the code, right? It's just showing the 3 rules. And then, if the string, if the name also start with an underscore, then we are not going to lint this constant either, right? And then this is so then we are here in this scenario that we found a constant that we need to lint, right? And then we use this pass with this report function. And I already created the diagnosis, let's say. And basically here is what we're saying. In this position, in this token position, between these 2 tokens position, I'm expecting the unexported constant should be prefixed with here, with the underscore, right? And then later on, we are also going to suggest a fix. But let's first see it working, okay? So nothing fancy, but we created our first linter. Let's go back here. And then, so what's the benefit of this, right? The stylistic linters helps a lot to reduce the cognitive load, right? Let's say when you have a PR, the last thing you want is, yeah, sorry?
I think you forgot underscore error. It should fail, no? You start with underscore and following with error.
Yeah, that's a very good point, yeah? So let's say, you mean that we would have something like this, right? Good. Like this, no? And then you continue in this case, right? No, you lint it. Yeah. Then we can do like this as well. And then you can do it, for example. Yes, let's go back here. What I was saying is that the stylistic linters help a lot to reduce the cognitive load, because at the end, what you want to focus a bit is in the business logic that you are implementing, right? If it's covering all the scenarios that you are interested, etc., more than, let's say, already agreed coding guidelines. And it helps a lot to be consistent as well, right? Which is a really good feature in a project in a team, right? And I want to give you an example of how we use that in our company, right? I have here an example of a PR, right? It's just a small example that basically you need to pass an input, and then you need to, let's say, return the name and surname of that string, right? And I want you to play, let's say, if you would see this PR, what would be one of your first comments that you would say? What would be your first thing that you think it can be improved? Any comments? It seems fine, right? More or less. But let's go to the next slide and we see a bit what was happening, right? This is the commented PR, right? Then we have someone saying, you didn't put T parallel, right? Also, we are not using table-driven testing in this way. We are creating a map, right? And then passing it, because before, if you remember, it was in line in the for loop. Then as well, let's say your package name is called name parser, and your struct is called name parser. You can use just the name parser, for example, right? Then we don't use actual and expected. We are using want and got as variable names. So you can see how it can, it can go yeah, to the infinite if you want. Then we are also comparing first got and then what you want, right? And then you don't need to use test fatal. You can use the dot error, and then you can also put the failure in the failure message the function name that you want to that you are testing, right? Everything but this, right? And what happened here? So let's go back. That, let's say you're not covering so many scenarios in this case, right? What's happening if you receive an empty string? What's happening if you receive only if the user doesn't have a name, right? What happens if you use a name from this country that has a lot of consonants? So there are a lot of scenarios that are not covered, right, in this test scenario, and your PR was basically all about these kind of things, right? Well, we saw already the benefit. We created our first linter, and we also saw the benefit of it. And now let's integrate our custom linter. Well, one of the options is to run it as a standalone binary. So you basically build it and then run it over your source code. And the other option is to integrate it in golangci-lint, right? You integrate it as a plugin. It's important to mention that because, let's say, golangci-lint already has a lot of linters included, right? And it's a bit hard if you want to create a linter that is integrated there. But you can create your own custom binary of golangci in which you include your linter as a dependency, and then you can run it, that custom binary, over your source code. So let's go. So we have here the business code, right? The business logic of our linter. And now, if we go to this project, right? Well, actually, we can see it here. Maybe it's easier. We just have this really small project that in which we declare a constant here, right? And then we are printing if you are, let's say, above this age or not, right? Then if we use golangci, okay, we're gonna run it. Let's say if we now do something like this, we are gonna create our own binary of golangci with our linter integrated, and then we are gonna see how we are gonna lint not only previous issues that we could have, but also this new one saying that this unexported constant doesn't have an underscore. It's running this, right? It created their own binary. It's running also the formatting, and it's running also the fix. And then we see here, right, this message that we created before. Pretty nice, right? And then to finish, I would like to propose that we implement a fix for this linter, okay? So if we go back to the source code, I have here, I have here this, well, when you create this diagnostic struct, you can also propose, let's go here, a suggested fix, right? So then when you run it with the, minus fix, this fix is gonna be applied, okay? And then basically, what we are doing is that based on the token, right, on this, based on this token position for this identifier of the constant name, we are gonna prefix it with an underscore. And then I have a question for you. Let's say, Do you see potential issues by doing this?
Bring references to that constant.
Exactly. So say you're going to change the constant definition, but you're not going to change when you use it, the reference to that constant, right? So then, if we go back to this custom plugin project, right? Then we're going to see that this is going to get prefixed, but obviously this is not going to compile. So watch out when you are proposing. Okay. So, is it better? No? So watch out when you are going to propose a solution, because it can be that you break the code, right? And then we can just for fun see it, right? We propose a solution, and then we are going to run again, make lint. We added our linter as a dependency, right? Then we are creating our own. Hello? Yeah. We create our own binary, right? We run it with ---- fix. Then the linting issue disappear, right? It's no longer here, right? The linting about the underscore. But we saw it here changing in real time, but the code is not compiled, right? So watch out if you propose a solution, a fix. So these are my takeaways after this demo. As you saw, it's relatively easy to create custom linters, right? You just need to traverse the abstract syntax tree. It can help a lot to reduce the cognitive load. We saw it in the example that we were focusing a bit more on how to, let's say, on good practices, right, instead of on the business logic itself. And it can be also an enjoyable experience. I have some linters open source. Some of them are available in golangci-lint, and actually enjoy when people use it, right? And this is it.